All right, so we have made it to chapter 11, which is called a power series. And in 11.1, we're going to do approximating functions with polynomials. We're going to do our best to get this stuff. We got 4 sections through chapter 11, and then we'll wrap it up. This is strange, and it's useful. It's useful for when we can't integrate things. That's the whole reason. A lot of things can't be integrated, but we can find approximations for them. So this is a great way of doing it. So we're going to begin with this, and we're going to do our best to understand what the heck a power series is. All right, so I'm going to make these videos fairly short, just so we can kind of get small points. So what is a power series? So there's 2 different forms. I wrote the simpler one, which we're going to talk about being something called a Taylor series, but that's neither here nor there. And just writing it in, because we got C's and X's and K's now. So I wanted to make sure to write in the K's just to start off with. Like, that's what's changing. That's what's going to change. So if we're to write this out, we would get C sub 0, since we're starting at 0. And then we would get X to the 0 with. But I'm not going to write X to the 0 with, right? That's 1. All right, there's our first term. Plus, we go to our next one. We're like, well, that's C sub 1. That's some constant. We don't know what that constant is, but we're going to find out soon. And then our next is going to be X to the first, and so on. It just keeps going. C2, some other constant, times X squared, plus, and then it just keeps going. Dot, 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 all the way up to plus some C and some X sub n. So these are our, just to start off with, this is our nth degree polynomial. And you're like, what? Yeah, it's a polynomial. What if we were just looking at this? Let's say C0 was 1 and C1 was 2 and C2 was 3. Well, wouldn't we have 1 plus 2x plus 3x squared? Isn't that a parabola? It's a parabola. So we're going to be able to create any sort of polynomial function we want, and it's going to be a great approximation for other things. And you'll see in a second. But for right now, just saying, hey, do you see that that's how we open it up? That's how we run stuff, how we use our indices. And then we can keep going with this thing, and we'd be like, this is C sub, and I'm going to stop color coding. It takes too long. Plus, dot, dot, dot. And then we have more, and then right over here, the terms continue. But I just want you to see, if nothing else, hey, when it's set up in such a manner, you create a polynomial. If you have it set up where it's some C that changes, some constant times some X in here. And we're going to start having a whole way that we get this done. And there's going to be a point. So this is the simple way of doing it. Now let's write in the general form, because some old dead dude took credit for something on the simple form up top. Might have a name and everything. But that's the general form. And we say that the center of the series, the center is A. And whatever, I'm just letting you hear the terms for right now. Well, it'll start to make more sense possibly soon. So our first term is C sub 0 times X minus A to the 0th, which I will erase immediately because you raise anything to the 0 with power, and it is 1. We're not raising C to any powers, we're just calling it different terms. So that just goes away. And it's going to follow the same form as we had before. So this is our first one. So it's C sub 1, and then X minus A to the first power. Oops, that's a plus sign. Golly. Times X minus A, but now we got to say it's the second term, and then squared, plus dot, 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 and it's going to do the same sort of thing. Except we're centered some terms, so around A. So this here is an nth degree polynomial. Maybe a 3rd degree, maybe a 5th degree. I just don't know. an nth degree polynomial, and then the terms can continue. N plus 1, n plus 1, plus dot, 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 and it keeps on going. And then there are the rest of the terms. The terms continue. So we got to have that down just so we're, can you put your indices in the right spot? Can you expand it out to where we can see what the heck is going on? Yeah. So this whole thing, this entire piece here, that's a power series. This is a power series. The entire thing, we call it a power series. Yeah. Maybe you can call it a super polynomial. That's what your book uses. So let's talk about these terms. I'm going to take everything out for just a moment, and then we're going to go to our next video so we can just keep it a piece at a time. Because if you're just trying to figure out how to solve the problems, you're screwed. You actually have to kind of understand what's going on. Maybe you can do that. So if you're looking for, like, we'll do an example problem. Well, you're going to have some trouble on tests if you don't understand what this is. So let's just look at our first term. This would be like y is equal to some c sub naught, or for example, y is equal to 4. That would just be a line. Y equals 4. Okay? Just a constant. We've seen a constant before. But what happens if we took our first and our second term? What do we have? Actually, I think it'll be a little easier to look up top. Let's get the x minus a's out of there. So what if we were to just look at this part right here? Well, you have a constant plus the slope times x. This could be b plus mx. Y equals mx plus b. It's a line. The first two terms will just create a line. You take the first three terms, and now you have a parabola. That's some sort of c plus bx plus ax squared. I know it's written backwards, but have you seen these? Have you ever seen the quadratic formula? That's all these are. So every term we go further to will create another type of polynomial. And we're going to use these polynomials to approximate things. It's called a linear approximation. Possibly your Calc 1 teachers went through it if you took it with me. Nope, I didn't go through linear approximations. I figured we'd just learn it here because you've seen it all. So this is going to be our beginning. What's a power series? Well, it's of these two forms. This is the simplistic form. This is the general form. And you're going to see a lot of it for the next few sections. So this is going to be our life. So we can approximate other things. So, all right, buddy. I will see you in the next video. Hopefully some of that made some sense, but not too much. Just how to plug in your case, noticing a few things, and understanding what a power series is. All right. I'll see you in the next one with actually doing things. See you.